Hello, everyone. Today we will start off our Sci 612 lecture based on the first module of our class, um, titled Introduction to Psychological Statistics and Measurement. I am quite aware what many of you might be thinking in relation to this course. You might be asking yourself, did I study psychology because I want to understand people? That's my goal. I want to understand people. Why do I need all these numbers? Yeah, your question is quite fair, and I'm going to try to answer you in a few minutes, very brief lecture. So I will tell you exactly why statistics is important and some other basic things involved. So statistics is not your enemy. Statistics is a simple tool, a very powerful tool that will help you move from guessing about human behavior to actually knowing something about it. Without statistics, psychology would just be storytelling. But with statistics, psychology becomes a science. So think of statistics like a doctor who says, I think your blood pressure might be high, which is a guess. But a doctor who measures your blood pressure and says, your reading is 150 over 95, which is significantly above the normal range. The doctor is using data and tools to give you something precise, something you can act on. And that is what psychological statistics does for us. So by the time we finish this topic, you'll be able to understand what statistics is all about and how to organize and describe data. So what is statistics? Statistics is the science of collecting, organizing, analyzing, and interpreting numerical data. In psychology, we use statistics to answer important questions. Questions like, does a new counseling approach actually help people manage anxiety? Are students in Nigerian universities more stressed during examination periods than at other times? Is there a relationship between economic hardship and rate of depression in Owerri? None of these questions can be answered by opinion alone. We need data, and we need the right tools to make sense of that data. So we must think of statistics as the grammar of scientific reason, just as you need grammar to communicate clearly in English. You need statistics to communicate clearly in science. So let's look at measurement. What is measurement? Measurement simply refers to the process of assigning numbers to objects, events, or characters according to a set of rules. Before you can do statistics, we need data. And before we can have data, we need to measure something. That is why we must understand the concept of measurement. And like I said, measurement is a process of assigning numbers to objects, events, or characters according to a set of rules. In this definition, the important word here is rules. We do not just assign numbers randomly. When a clinical psychologist scores a patient's answer on the Beck Depression Inventory, which is an instrument used to measure depression, or when a researcher measures how quickly someone reacts to a stimulus in milliseconds, there are clear agreed upon rules governing those numbers. Let's look at a simple analogy. Think of measurement like a ruler. A ruler has a defined starting point, equal spaces between the markings, and a clear unit of measurement. Rulers could come in centimeters or inches. Without those rules, two people measuring the same object could arrive at completely different numbers, and neither result could be trusted. So measurement in psychology works the same way. And there are 4 scales of measurement. Now, this is very important. If you must learn statistics, you must know the 4 scales of measurement, just like you know the 5 fingers, just like you know your 5 fingers. Measurement, the 4 scales are probably one of the most fundamental concepts in the entire statistics. It will guide you, and it is important that you must know the scales of measurement. In 1946, a psychologist named Stanley Stevens proposed that there are 4 different levels or scales of measurement, and each level has different properties and permits different types of statistical analysis. And in the course of his work, he named 4 scales of measurement: nominal, ordinal, interval, and ratio. The nominal scale is the most basic level. At the nominal scale, numbers or labels are used simply to categorize things. There is no order, no ranking, nothing mathematical about these categories. They are just names. For example, if a researcher asks participants to indicate their ethnic group, you will hear people say, I am Igbo, I am Hausa, I am Yoruba, I am Igbira, I am Ishekiri, I am Nupe, and so on and so forth. This simply is nominal data. If I call you and gather you to a class and ask you to classify yourself based on gender, all of you will either fall as males or females. And in the Western world, we have other type of gender. You can count how many people fall into each category, but you cannot say one category is more than another. This is very important about nominal variables or nominal scales of measurement. No category is higher than the other. And for us in statistics, when we collect data using nominal data, we tend to use statistics like mode, frequency count, chi-square test to analyze it. So these are some of the tests we are going to do in the coming weeks. So let's look at the second scale of measurement, the ordinal scale. The ordinal scale adds order or ranking to the categories. Remember, at nominal level, the categories are there only. No order, no arithmetic, nothing. But when it gets to the ordinal scale, we have ordered categories. However, we do not know that one value is higher than the other. But you do not, or we do know that one value is higher than the other, but we do not know by exactly how much higher. Think of class ranking. If 3 students ranked first, second, and third in their class test, or just merely ranking, you know who came first, but you do not know whether the gap between first and second is the same as the gap between second and third place. Let's take, for instance, 3 students in a class may score first, second, and third. The aggregate of first, the average score of first may be 600, while the score of second may be 590, while the score of third may be 350. You see that they have unequal interval. The difference between the first and the second is quite slim, but the difference between the second and the third is quite huge. Researchers use Likert scales. Likert scales, Likert, to obtain responses from respondents. And these Likert scales come in the form of a scoring format where you have strongly disagree, disagree, undecided, agree, and strongly agree. Now, technically, this scale is ordinary. If someone says he strongly disagree, the person may not be able to quantify by how much he or she or they strongly disagree compared to somebody else or a respondent who thinks strongly disagree rather. So technically, these are ordinal scales. And we use, to measure ordinal scales, we use statistics like the median, the percentiles, and the Spearman rank correlation to analyze ordinal scales. The third scale is the interval scale. The interval scale has all the properties of ordinal scale. It is ordered, it's in categories, it is ordered, but how the intervals between points are equal is difficult to determine. The interval between the points are always equal. A classic example is, let's say, temperature in degrees Celsius. The difference between 20 and 30 degrees is the same as the difference between 40 and 50 degrees. However, there is no true 0 point for temperature. 0 degrees Celsius does not mean no temperature at all. In psychology, IQ scores are treated as interval data. A score of 0 on an IQ test does not mean zero intelligence. With interval data, we usually calculate it using means, standard deviations, and other powerful tests like the t-test. The fourth scale of measurement is the ratio scale. The ratio scale is the most powerful scale of measurement. This is because it has equal intervals and also a true 0 point. 0 means the complete absence of whatever is being measured. For example, reaction time in milliseconds is a ratio scale. 0 milliseconds would mean no time at all. Also, the number of panic attacks a person experiences in a month is also a ratio data. 0 means they had no attacks. With ratio data, statistical operations are permissible, including multiplications and divisions. Let's look at counting versus measuring. Organizing data into frequency distribution. There is one more important distinction that we need to understand before we move to our next section. Counting produces discrete data. Discrete data are whole numbers that cannot meaningfully be split into fractions. You can have 30 students in a class or 31 students. You cannot have 30.5 students. Your father can build a 3-bedroom bungalow, but he cannot build a 3.5-bedroom bungalow. So measuring, on the other hand, produces continuous data. That's the difference. Data that are continuous data have values that can, in principle, take any value within a range. For instance, our body weight. Someone can weigh 10.5 kg. Another person can weigh 90 kg, while another will weigh 60.6 kg. It's very possible. Reaction time too is also a continuous variable. So this distinction matters because many powerful statistical tests assume continuous data. When your data accounts, different statistical approaches are required. But when they are when they are in continuous data, different statistical tests are also applicable. Frequency distribution. How to organize our data so that the patterns become visible. That is bringing order to chaos. Usually, once you have collected data, the first thing you want to do is to organize it so that patterns become visible. Imagine you have just administered an anxiety test to 20 new PGD students, and you have a list of 20 raw scores. What does that tell you? Very little. But when you organize those scores into frequency distribution is a table showing how often each scores occur. Suddenly, patterns emerge. Let me walk you through how to build one. Like the table you see here, we have, let's call it the raw scores of a group of students. Let's call them 20 PGD students who took an anxiety test. You can see there that the students scored from 3 to 8. That's the score that was obtained. And then the frequency marked as F indicate the number of persons that had those scores. 3 was scored by 2. 2 persons scored 3. 3 persons scored 4. 4 persons scored 5. 5 persons scored 6. 4 persons scored 7. And 2 persons scored 8. You add that together, you get 20 participants. And that's the frequency. And from here, you can have real frequency percentage, which is very easy to calculate. Two divided by 20 times 100 over 1. You get the percentage. Then we have cumulative frequency. Cumulative frequency has to do with the addition of the frequency. The first frequency score there is 2. And you add 2 to 3, the second frequency score, you get 5. And you add 5 to 4, which is the third frequency score, you get 9. You add 9 to 5, the fourth frequency score, you get 14. You add 14 to 4, which is the fifth frequency score, you get 18. And you add 18 to 2, the sixth frequency score, you have 20. Graphs. A frequency distribution table is excellent, but a well-drawn graph communicates patterns even more rapidly. It is easier to understand data when they are presented in graphs. In psychology, we have 4 main types of graphs, although there is a fifth one, which we will also discuss in class. The histogram, the bar chart, the frequency polygon, and the stem leaf plot. We also have the pie chart, which we will also use. I will encourage you to try to distinguish the differences between the histogram and the bar chart, the frequency polygon, and the stem leaf plot. So finally, we have been able to understand the concept of statistics, which is the science of collecting, organizing, analyzing, and interpreting data. Statistics is not grammar. Rather, it is the grammar of scientific reasoning in psychology and in several other disciplines. Stevens in 1946 was the person who derived the 4 scales of measurement: the nominal, ordinal, interval, ratio scales of measurement. And this we use to determine which statistics are legitimate, which statistics we use. Using the wrong statistics is not just wrong, it is scientifically meaningless. So for you to decide which statistics to use, you must know the data type you have. And that is why I said that you must know nominal, ordinal, interval, and ratio scales of measurement, like the fingers in your palm. In terms of data, we have discrete and continuous data. Discrete are counted data. That's data that uses whole numbers. While continuous data can take any value. This distinction determines which statistical tests are appropriate to. So it is important that you know the difference. Frequency distribution organizes raw scores into a table with 4 columns. Score, frequency, relative frequency, and cumulative frequency. And finally, we learned that graph is determined by data type. Histogram is used when we have certain data type. Bar chart is used when we have other data type. And stem leaf is also used when we have other data type. I will ask you to read further in your notes to understand this better. I will also supply you with supplementary materials to understand this. I thank you for listening and hope to see you in our next class. Have a lovely day.